like weirdly close to you. All right.
I'm Tommy Minyard. I'm Director of Advanced Computing Systems at TACC. I've been at TACC for over 20 years now. I started in November of 2003, so I've seen the whole evolution of systems at TACC.
Okay.
I actually started in the HPC group, had developed applications and everything, but when I was in graduate school, I had built clusters and everything, and at the time we were looking for a new systems lead, and so I ended up basically talking to Jay at the time, and said, hey, why don't I take over the systems role and help run things, and because I'll bring an HPC point of view to the system side, and so I became this leader of the systems group. And
okay, so wait.
So that was in 2007 timeframe. So for the last 16 years, I guess I've been lead for the systems group.
Very cool. All right, so what are you excited about right now?
Right now?
What are you feeling like this is exciting and we're doing this?
There's a couple of big things that I think are exciting in our space right now, and the number one that I'm most excited about for the new systems is going to be our VAST storage system. So we have done VAST storage system.
Okay.
So they have an all-flash based storage architecture. We've typically run big, large, parallel Lustre file systems, and that's been our storage of choice. But with the new technology of Flash and the capabilities it provides, it completely changes how the file system can be architected, and you don't have to deal with spinning disks anymore.
I'm backing up because you said big and large, and I was a grammar teacher. So big, large, what does that mean?
So for us, that typically mean on the order of 12 petabytes, being able to do over a couple hundred gigabytes a second of bandwidth, and that's pretty big for us. On Stampede3, we had 15 petabytes of storage, and so now we'll have 12 petabytes on Stampede3. And VAST will also be used on our new Vista system as well. From a systems point of view, every day is a challenge because every day you stumble into something new that breaks or doesn't work the way you expected, or you have to fix.
I see y'all in there all the time, fixing everything.
And it's also cabling and building and uncabling and deconstructing systems. So it certainly keeps us occupied. But with Stampede3 and these new systems coming, they're really going to augment what we already do with Frontera and Lone Star 6 now. I like kids. I lost track of all the names of the systems. So I think they're going to provide a lot more capabilities that the user community needs, and hopefully lead into the next big leadership class computing facility that we'll deploy in a couple of years. So the systems we're deploying now, like Stampede3 and Vista, and those are all new technology that we're trying to evaluate and figure out if it's going to really work for what we need in the next generation systems. And really the key for us is to making sure that the users can actually use the hardware and that they can get their science done, and that they don't have to report and rewrite a lot of their stuff to be able to use it. And that gets in the way of their science. They want to get their research done. For us, we want to make sure that we're building the right architecture that the largest number of research groups will be able to utilize the most effectively to get their research done. So that's why we're evaluating a lot of these technologies, and we think things like the new Grace Hopper platform, the new Grace chip from NVIDIA, the new VAST flash file system. We think that these things are key aspects to what could be in the next generation system.
Okay, I did this annoying thing where I do a high five at the end. Thank you. Thanks for hanging out.